versus version 2.0. So you will need to know about it, because in interview, people will ask you about these architectures. Now, Hadoop architecture, if you ask me, it's not that complex. It takes a couple of minutes to understand that part. So I will spend 30 to 40 minutes to make sure we understand the architecture, because two architectures are kind of distinct. Version 1 and version 2 are kind of distinct, and you should know about it. Then we'll take a quiz just to see how are we doing. Okay. After that, either we take a break or we'll start with the creating EMR. So today my goal is to create EMR cluster. EMR stands for Elastic Map Reduce. Elastic Map Reduce Cluster. So here, good news, we can work in a browser. We can work with browser and we'll connect with AWS Cloud. Now, for this exercise, you need to have AWS Management Console account. If you don't have an account, you can create that account. It may take a few minutes. You do need a credit card. You need a credit card to create an account. Again, you should have an account for AWS in order to do so, which may take a minute or two to create an AWS account. Once we do that, we're going to create a cluster, EMR cluster. EMR cluster normally take 4 to 5 minutes to create. Once we create that, we're going to run HDFS command. HDFS command, we're going to do around 10 to 12 commands, which is very common. You will be using almost on daily basis. And then we will discuss about our homework, and that will be a last exercise for the day. Homework is very similar as what we are going through as a command. So homework has two sections. One section is architecture, and the second section is HDFS command. Now, if you pay attention tonight, and if you are able to do this EMR, if not, you can also do later by watching recording. If you do HDFS and Hadoop, I can give you guarantee you will feel confident, because HDFS commands are very similar as a Linux command. Once you know about it, you can now easy to interact with Hadoop cluster. Everywhere you work, you must know about HDFS command. Though are easy, we have very well documentation, so it's not going to be trouble. And the homework is very similar to that, so you can practice that. Once we complete that, when we come next week, we're going to start a new component called pig, and that is what our pig will be, a data flow language, and that is what we'll cover next week. Program. So there are two type of thing. One is called manager machine. Please relax and enjoy. And the seconds are called slave. They are slave in the sense of they are machine, do not have a management aspect. So they are more worker. So we call worker, right? Worker. So they are kind of worker. So you as a client, you normally send your program here. You send your program here or command here. So when you send your program or command here, the manager reads the command and convert the program into small tasks. So you convert the task. The program is divided into tasks. And then this manager knows where we should send the task. And it send the task to available worker node. And it knows how it distribute the workload. So first is the program. Sometimes we call job. Program is also we call job, which goes to first manager. Manager will take the job and say what kind of things they are asking. And then they divide the job into small tasks. And then task will be routed to the worker node. And you can have one node or you can have n numbers of nodes. Hadoop version 1 was able to support thousands of nodes. So you can go up to thousands of nodes, no problem. But Hadoop version 2 can go up to hundreds of thousands of nodes. So Hadoop version 1 was designed for thousands of nodes, but Hadoop version 2 is hundreds of thousand nodes. So the first problem with Hadoop version 1, it can scale up to certain limit. It was not like infinite. So anything you try to do, there was a limit. So this machine, how many machines you can have, how many machines you have here, that was a limitation on version 1. Why? Because you have only one manager. So if you're only one manager and you have multiple slaves, when we are talking about 500,000, and if you go beyond, now you're hitting the limit because one manager was not able to communicate with thousands of worker nodes. So this was one problem. Second problem, what if manager goes down? If manager crash, then the task which you routed, the task you routed, no one knows about those task detail. So what happened with the task? So in that situation, when manager dies, everything stops. Now you need to rerun again the job, entire job. Listen carefully. You need to rerun entire job because managers die or restarted. You have to rerun. So you have to start over. And sometimes managers completely crash and there is no other setup. So if you don't have one setup, it's called SPOF, single point of failure. Single point of failure means if you have one manager, if that manager is not in a working condition, Hadoop cannot work. So this is like the biggest, I would say, bottleneck. Because you have one manager, that machine may have outage, may have some corruption, may have something hard drive failure. In that situation, entire cluster become like a, you cannot operate it. Completely goes in a situation where it's useless. So this was the big problem with Hadoop version 1. It has two components. So one component we call job tracker. Job tracker. So you are taking a job. So job in the sense of if customer sends me a job is nothing but program or request or command. So when customer say I want to run one job, the first thing, the job tracker receives the job. As I mentioned, job tracker receives the job. And then they divide each job into tasks. And then it knows how to send this information or task to the worker node. So there are many worker nodes. There are many worker nodes are there. Now, how many worker nodes you have, how the works happens, the magic is a Hadoop framework. Hadoop framework maintain the repository about available worker nodes. So what happened? Please relax and enjoy. There is a small component called Zookeeper. There is a small component called Zookeeper. Zookeeper is very simple, easy software. The Zookeeper, every worker node, when they start, they install the software, they register to Zookeeper that I am available. Another worker node registers I am available. And every worker node will register their information that I am available. Now, when manager starts, manager will make a call to Zookeeper. Zookeeper is nothing but a registry where everyone has registered. So when manager start, manager say, hey Zookeeper, how many worker nodes we have? And then it will know. So now in this situation, let's say I have one worker node 2, worker node 3, worker node 4. But it is possible that one worker crash. In that situation, this information will not come to Zookeeper. So Zookeeper will mark that worker node is down. And in that situation, manager requests how many worker nodes we have. It will send only one worker node 1, worker node 2, and worker node 4. By doing this exercise, always manager doesn't need to know how many worker nodes are there. Sometimes you, let's say if you want to add new worker node, let's say you add one worker node and you register. When manager requests, now that worker node information will be provided. So this is called decoupling. Decoupling means at any time, you can add worker node. At any time, you can add worker node or you remove worker node at any time. Why? Because Zookeeper provide that kind of flexible service aspect. It means manager doesn't know worker node does not know manager. They all rely through Zookeeper. So in interview, people may ask you, what is the purpose of Zookeeper? So purpose of Zookeeper is very simple. It kind of allow worker node to register, and then manager can inquire the Zookeeper to find out how many worker nodes we have. So it's kind of registry. You can say it's a registry where worker node register themselves and the managers can find it. So there is no direct connectivity. between worker node and the manager. By doing that, you can add anytime, you can remove anytime, and you won't have any problem. Any questions so far? So Zookeeper, you can think about database. Zookeeper is a database. So like example, you start, let's say you start the, what do you call, worker node, start the machine, it will enter one record. It's just like a data. It say I am in, so it knows the machine IP address, it knows where it is located. Another start, it adds another entry, another record, another start, another entry. So this way you are keep adding the entries in the Zookeeper. So Zookeeper is actually simple repository. It has a database called etc, which kind of allows you to add, hey, I'm available, and then information is available. And then Hadoop manager will make a call to Zookeeper and say, how many worker nodes you have? And this happens all the time. They continuously tell this worker node has every few minutes, they have to tell I'm up. They have to continuously tell health signal. So Zookeeper knows every few minutes if the machine crashed or machine is available. Like in this situation, machine was crashed, but then you restarted. After a few minutes, it will start sending the signal. Then worker nodes information will be updated. So Zookeeper knows now this many worker nodes are active. And now next time when manager say how many worker nodes we have, manager will get the information through Zookeeper. So Zookeeper kind of become like a, what do you call, it's a adapter. It's kind of a buffer between manager and worker nodes. This concept is called service locator. This is called service locator or registry. It's kind of registry where easily manager can find their workers and workers can easily register without knowing tight coupling. Tight coupling means, like example, if worker node directly to connect, if this manager goes down, then he can't do it. But here manager, it doesn't directly connect to the manager, it connects to the Zookeeper. So whenever manager is coming up, manager will get that information. Manager you can restart at any time. Worker node you can restart at any time because they are decoupled. So it gives you a little bit flexibility. So far so good. Any questions on phone so far? Okay. So in manager, there are two programs are there. First program is called job tracker. Job tracker is the main program. Please understand, job tracker is the main program. It receives the job information, then divide into tasks and send the task to the worker node. Job tracker role is very simple. How do I execute the job? How do I execute the job? And in order for to execute the job, it will send this task to different worker node. Now you may say, can I have one worker node? Yeah. Can I have 5 worker nodes? Yeah. Can I have 500? Yes. More worker node you have, more parallel processing you can do. And that's why whenever somebody say Hadoop, they talk about Hadoop cluster. Cluster means bunch of machine together. So if you do this, it's called cluster. Cluster means bunch of machine together. Now, as I said before, there are two problems. Problem number one, you cannot add infinite worker node. That's the one problem because you have only one manager. It doesn't scale. Second thing, if you have only one manager, then that manager crash, then Hadoop cluster become useless. So now, first we talk about job, which is the program, but there is another program running in a manager that call name node. So that concept is called name node. Please understand name node. So name node, this name node has a very special concept. So please understand, it's confusing. There are two lanes. So think about lanes. There are two lanes. If you focus on that, you will understand. One is called programming lens. So if you think about programming lens, then you do program, then you have job tracker, job tracker. Job tracker means you receive the job. And then you go here, then they call task tracker, task tracker. So all the task who is receiving, they are called task tracker. So task tracker means it receives the task. It receives the task. These are machines. These are just machine, your laptop or desktop. It's nothing special. But there is a program running. That program is receiving task. So whenever we talk about length of program goes to job tracker divide the program into task and then send it to task tracker. Whenever I say task tracker is nothing but worker node. That's one lens. But there is another lens which is called data lens. That's called data lens. So there are two lenses we need to understand. So data lens means this customer is running program, but he need data. So what happened? There is a one program which is called name node, knows about where the data is stored, and data is also stored in a worker node. So worker node has a hard drive, data is stored. So name node keep track on where the data is stored. Based on the data, it will send a task. So example, let's take an example. I want to process USA file. So I have US data. Please relax and enjoy. I have US data. So now if you send data, it will go to name node. If you talk about data, it will go to name node. Name node will take the data and then it will slice the data into small chunk. And that chunk, normally there right now is 128 MB chunk. That 128 MB chunk, it will send to particular machine, either here, here, or here, or here. Now, name node will maintain a history that I had a file 1 and I created a chunk and I stored that chunk into data node 1, and chunk 2 I store in data node 2. This type of repository name node will maintain. Why it is necessary? Because Hadoop pass that file into different machine as a chunk. The reason it pass it, so in one chunk, if you have Michigan will go here. You have, let's say, Illinois, let's say you have New York. So each data node may have a specific file, let's say California. Now your data is divided. Michigan is here, Illinois is here, New York is here, California is here. Now, second thing, job comes. Now, first task is, let's say, New York. Then that will go to the machine where the New York data is located. Let's say Illinois, then it will go to that particular machine where Illinois is located. So job tracker and name node, being they are in one machine, job tracker will talk to name node. Hey, where are these Illinois file? Name node say, wait a minute. I have everything in my memory. So from memory, it will say, oh, you're looking for Illinois. It is in a data node 2, and job tracker will send the task to that machine. By doing that, you're processing only Illinois data to particular machine. So now you're processing Illinois, same time, Michigan data and Michigan job will be running here. So you can see you're doing parallel processing. And here, same thing if you do New York and same thing if you do California. Once the process is done, everything will be updated to name node and then customers will get the data response back. So customer does not know all those things going on. But because the manager has two things, how to organize data, and how to keep track where data is stored. Second thing, manager has a job tracker. Job tracker knows how to divide the job into tasks and send it to particular worker node where data is already there. It sends program or task to the machine where data is already there, because you don't have to shuffle the data. If you don't have to shuffle the data, it will be very fast. Because if you shuffle program is tiny, it's kilobyte. Data is in a megabytes or in a gigabyte. So you're not shuffling data, you're shuffling program. And because you're shuffling program, it's lightning fast, you can send it to machines. And data is divided into particular segment, like example, in our case, state. So you can process Illinois data parallel and Michigan data parallel. They are all parallel. They are not hitting each other. And because data is sliced into multiple segments, Hadoop can do parallel processing. Now, the worker node has also two names. Sometimes we call task taker, and sometimes we call data node. These are lenses. So if you are a client, please pay attention. The client, first thing they will say, hey, manager, I want to store data. So first it will say, I want to store data. Let's assume I have Illinois and Michigan data together, just an example, as a file together. So this one will come to name node. Name node say, oh, you're sending me data. I have, let's two machine for time being. I have two machine, and this is machine can be named as a task taker or data node. So here I'll say 2, and here I'll say 2, and this is 1. So what name node say, wait a minute, you're sending a file which is big. Let me create a slice. So it will create a slice Illinois, and it will create a slice Michigan. Again, I'm just giving an example. Now name node say, you know what, if I send all here, then at single point of time, only one program can run. So this name node is smart. It say, you know what, I'm not going to send all to one data node. Rather, Illinois file, I'll send it to data node 1. So it will store here Illinois file. It will store Illinois file, and it will maintain that this file is in data node 1. And then Michigan file, it is stored in data node 2. So it will maintain. This is called repository, where the data is stored. This is in memory of name node. Now the client say, you know what, client send, hey, job taker, I want to run a program. So what program you want to run? Let's say I want to know salary calculation. So the job node say, okay, I got the program. So now let me create this program into two tasks. One program will calculate the salary for Illinois, and one program will calculate the salary of Michigan. So now Illinois program will go here. Why? Because the reason it goes here, because this Illinois, it will talk to name node first, and it say where the data node. So name node say it's in 1. So based on that 1, your information will come here. So that is coming as a task 1. It will come with the Illinois. Now this program comes to task taker. Task taker is the program recipient. It reads the data and start processing. Then the job taker say, you know what, I have another task which is called Michigan. So it will ask, do you know where is the Michigan? So it's the Michigan is second machine. So now the program will go to here. So program will come here. The program say, I'm coming here to process Michigan, and the data is there. So now this is working parallel. When they complete the program, they will inform name node that I'm done. They will inform name node I'm done. Now name node will aggregate these answers and send it to client. Because the data was divided into chunk, job taker was able to do parallel processing.
Look like if job taker is app, for example, in a computer, and then the worker here, worker is a slot.
It's the slave. Yeah. Yeah. Correct. Absolutely. It is a slot, but you are using a power of machine. So rather than using one machine, you are using multiple machine. Now, there are many things important to understand. First, if you're a large file, then you can slice into multiple machines. So more workers you have, what happens? More workers you have means more parallel processing, or massive parallel processing will happen because you have more workers. If you have more workers, what will happen? You can divide the task, Illinois, California, Michigan, New York, you can do parallel processing. And once done, you do aggregation. So this is a very important machine. The manager is very important. Sometimes we call master, or sometimes we call manager. So master node is called name node. Sometimes we call name node, and sometimes we call job tracker. Job tracker focus on program aspect. Name node focus on data aspect. And master is nothing but manager. Master is nothing but manager. So manager is going to do all those things. Now, any questions so far? Job tracker and name node. So this is the one machine. But just like in one machine has two type of function. One function is called job tracker. Job tracker means they take the job. And one is called name node. Name node responsibility is to capture the data, slice the data, and keep track on that where the data is located. So name node responsibility is I'm going to divide the data into chunk, and I'm going to store that into multiple machine, and I'm going to keep track on that. Name node, please understand, name node keep everything in memory. So name node needs lots of memory. Job tracker is more about program executions. So job tracker focus on more program. But Hadoop old version, everything was in one machine. So what will happen if that machine crash? You are in trouble. So far so good, people on phone. Any questions? Now, yeah, correct. And one is name node. They are two programs, right? Now, this happens long time back. So people, what they did, this master node, the master node can go down, means something happened. To solve that problem, many people, what they did, they copied the whole information what master node had, and then they created a secondary node. What they created? Secondary node. Secondary node is nothing but is a backup. If master node goes down, then the secondary node will become a master node. So this is a backup. Secondary node is your backup. So secondary node, they keep it for backup, because what if master node goes down, then secondary node also will have same thing, job taker and name node. It does have a same thing, but it is kind of offline. When when it crashes, they can bring it up. They don't have to install or anything. They keep it in a safety net. So it's just like a two car. If one car has a flat tire, now you can use the other car. And it's a spare wheel or spare car. Secondary node responsibility, just whenever name node goes down, there is no automated. So person like admin, Hadoop admin needs to start the secondary node, and then secondary node will act as a name node. So far so good. So when you go in interview, people will ask question, what was the problem with name node? So two things you always talk. One, name node has a capacity problem. Capacity problem means you cannot have infinite worker node. So up to 1,000, 2,000, no problem. But as you go further, it kind of slow down. So first problem was limitations on how many worker nodes you can have. So you cannot scale Hadoop version 1. Second problem was that Hadoop version 1, where job taker is single point, name node is single point, master node is single point. So everything is single point. Only one job taker, only one name node, only one master node. So if that machine goes down because of power outage or something, entire Hadoop cluster become useless. Now, everything happens using Hadoop framework. So whenever we say Hadoop framework has two things. One is a data aspect. So data aspect, whenever we talk about data aspect, name node comes and data node comes. That interaction happens through HDFS. HDFS means Hadoop file system. Hadoop file system keep track on the data. So whenever you talk about data, Hadoop file system comes in picture. Whenever you talk about job and task, then that aspect you talk about MapReduce. MapReduce comes for parallel processing. And these two framework together, we call Hadoop framework. So whenever somebody say Hadoop framework, it's these two things. Hadoop framework is two things, HDFS and MapReduce. That's all. Hadoop framework, one focus on data management and one focus on job and task management. And they all work through Zookeeper. The reason they use Zookeeper, so Zookeeper decouple point-to-point communication. Why? Because if you do point-to-point communication, then every time you add node, you have to restart name node. Because you're using Zookeeper, now you're decoupling. Name node doesn't need to be restarted. You can add anytime worker node, you can remove anytime worker node, and you will not see any issues. And this is a beautiful concept, and it works. It works like a charm. Any questions so far? Good. So this concept, if you ask me 2000, I would say 8 or 9, it started like this. And then people realized that in 2011 and 12, that this is good thing. Massive parallel processing, Hadoop is for batch processing. Hadoop works very well, but this limitation was one name node, one job tracker, and one master node. This is a limitation. To solve that, they introduced another thing called, we call YARN. YARN is nothing but Hadoop version 2. So what is Hadoop version 2 is solving Hadoop version 1 problem. So first of all, before you go to Hadoop version 2, I want to make sure, are we clear with the name node? What is the purpose of name node? What name node does? Name node keep track of data. It keeps where the data is stored. And you don't have to worry about it. Everything will be taken care. I'll show you how it works. Completely automated. You will not even know where the data is. It is automatically it's transparent to you. You won't even know. But name node focus on taking the data, slicing the data, storing the data to particular machines. The next one is a job tracker. Take the job, divide into tasks, and then using name node, identify where the data is so it can send the task to that machine. By doing that, it does parallel processing. So name node, focus on data management, job tracker, focus on task management. Worker node you can add anytime, you can remove anytime. They register or unregister using Zookeeper. So if you remove the Zookeeper, Hadoop doesn't work. So sometimes people say, why you need Zookeeper? So Zookeeper is kind of registry where workers register and name node reads about it. So it kind of decouple managers and slave, or master node and data node. It kind of decouple. So Zookeeper is just like a database. You can think about distributed database. It's a very light process. You can add anytime, you can read anytime, and it was open source. So Hadoop used Zookeeper for this type of decoupling. Any questions so far? Good. So now let's change this picture. What is Hadoop version 2? So Hadoop version 2 come up with multiple changes. So the first change is Hadoop version say that, when customers send the job information, that information will go to resource manager. So they introduce a concept called resource manager. So in Hadoop version 2, the concept is called resource manager. In a Hadoop version 1, that was job taker. It's a very similar as resource manager, but resource manager does very limited work. Job taker was doing a lot of things, but resource manager does only one thing, managing resource. So far so good. And in old fashion, you had a two thing, master node and data node, right? You only thing, two things, master node, master machine and data node. Now in Hadoop version 2, the concept is a little changed. So you have resource manager, and then you still have a what you call worker, but the worker has a lot of different program running. So now check it out. So resource manager is here. Resource manager, we are talking about Hadoop version 2. In Hadoop version 2, resource manager is there. The user will say, I want to store program or data. Sorry, I want to store data. The resource manager will say, where should I store? So these machines are called node. So node 1, node 2, node and node 3, just like worker node. And then this has a small program called node manager. Node manager. Node manager is available. Every machine has small program running node manager. It manages the whole machine, basically. Node manager is managing the whole machine. If you notice the Hadoop version 1, the data node did not have any program running. They were tasks. They were running tasks, but they were not self-managed. It was managed by job taker. While in a Hadoop version 2, listen carefully. In Hadoop version 2, each machine is smart. So this slave machine or worker machine are smart. They have manager. So now what happened? The client says, hey, I want to write data. So resource manager will check who is available out of things. So like example, this is available. So resource manager will send request to this node manager. Now node manager receive the request, and there are 3 programs running. One program is called container. One program is called container, and second program is called application master. Application master. So every machine has 3 programs: container and application master. Application master. Every node has the thing, the container and application master. So first thing, resource manager say which node is available. So now this node is available. So now this node receives the request. So when this node receives the request, node manager say, application manager, I got the request. Why don't you start running? So application manager will talk to container, and container will start running program. Now, same thing, next program comes. So resource manager will send here node manager, but node manager will try to see if application manager can run the program. Sometimes program is running. So node manager say, oh, I'm busy. I am busy. So it will send signal to resource manager. Hey, the program is busy. The resource managers will now send program to node manager. Now node manager send this request to application manager. Application manager say, you know what? Run the program. The application manager runs some program here, but now we need more capacity. Then application manager will ask resource manager, I need more capacity. So application manager can run some program here, some program here. So this type of intelligence allows this version, Hadoop version 2, to scale up to 80 to 90,000 machines. So the Hadoop version 1 was able to run only few thousand, and it was sluggish. But Hadoop version 2, because each machine is independent. So like example, if this machine crash, no problem, because each node has a manager. So they will continuously function. When this machine come back, they will start working. They also talk to each other through Zookeeper. So they also use Zookeeper to talk. Just like that, they register, they read and all. But each machine has a super intelligent. They have node manager. Node manager control entire machine. If this crash, then there is application manager. Application manager can run many containers and run multiple applications. So in old Hadoop, you can run only one task at a time. In a new version, you have multiple containers, so you can run multiple tasks in the same machine, and you can perfectly utilize the machine resources. If this application manager need more resources, they can talk to other machine. This was not possible in Hadoop version 1. In Hadoop version 1, each data node was controlled by the master. Only master can drive. Here, each node can reach out to their sibling and say, hey, can you run my task? If one task fail, listen carefully. If one task fail, then only you rerun that task. So you are still using the prior task. In Hadoop version 1, entire job fails. So if job has a 3 tasks, if you have 3 tasks, and if one task fails, then you have to run entire job. In Hadoop version 2, if task 3, out of task 3 fail, then you rerun the task to some other machine. So speed is there. Hadoop version 2 gives you speed. Hadoop version 2 gives you scalability. Hadoop version 2 have a resource manager, just focus on more resource scheduling. So it's more scalable.
You can talk each other through
Zookeeper. Yes, through resource manager. Through resource manager. Yeah, through resource manager, they can talk. Because think this way, like example, I'll give you the example. So let's think about restaurant. Like think about restaurant. So perfect example, let's say you are going to, let's say CPK. You are going for CPK. So if you are going for CPK restaurant, as soon as you enter, whom you going to talk? You're going to talk to restaurant manager, which is your resource manager. Now restaurant manager say, okay, how many? And then restaurant manager will ask waiter, hey, why don't you serve them? So now waiter is nothing but node manager. So far so good. Now waiter will get that. So waiter will say, hey, I got your request. Now waiter got the request, and the waiter will say, you know what? Waiter will get the request and it will go to kitchen. So when they go to kitchen, the kitchen here chef, right? He has a chef. So that is your application manager. Application manager, chef. He knows how to create food. So that's the application manager. Each waiter knows whom to reach out because they know who is the expert. Now application manager need some space to prepare the food, which is called table, right? So if you need a table to prepare the food or organize the food, that's called container here. So that's like a container. So think about that. Customer is not really talking to the waiter. Customer is talking to resource manager. Now let's say one customer say, I don't like the place. Waiter is not going to do anyone. Waiter will go back to resource manager and say, what should I do? Let's say I don't have milk or I don't have food. So, hey, I need an oil or I need this. So resource manager say, wait a minute, let me talk to this. And through that, it will overload or bypass some of the workload to other, because this restaurant manager knows whom to ask for help. Now, when it sent that, waiter knows whom to ask for the food preparation. And this guy knows what resources, table or other things I need, or table or chair. And that when it comes table and chair, they're not going to talk to resource manager because they are self managed. So you're kind of divide and delegating responsibility. In a Hadoop version 2, each and every node, each and every application has an intelligence there. So they kind of function independently, even though, like example, this guy is busy. If this guy is busy, this guy is now going to talk to this one and get the help. If this guy is busy, he's going to ask to here. So they kind of help each other. So Hadoop version 2 has a scalability and intelligence in place, which allows more scale, more parallel processing. So that's the first advantage. You can do more parallel processing. That's the first advantage. Second thing, you can scale better. Now there is another advantage. So far so good. Hadoop version 2 is not a single point of failure. Why? Because if you ask me node manager, this node manager is nothing but your resource manager. Resource manager is a global level, right? Resource manager is a global level. Node manager is the machine level. Machine level, this is itself is a resource manager, but machine level. So you divide and conquer, just like a president and governor, right? So you can divide and conquer. The beautiful part about version 2, in the old version, only two frameworks were had: HDFS and MapReduce. That's the only two framework you had in old framework in Hadoop version. Now, in a Hadoop version 2, the program the client sends, they can use program for Spark program. So they use Spark, they can use MapReduce, they can use different programming language. So this allows you can use different programming language. So first, it's support programming language. Second, Hadoop version 1 only was working with HDFS. Now, in what you call Hadoop version 2, you can use S3. You can use S3. S3 is the Amazon storage. You can use Amazon storage. You can use HDFS. You can use other storage also. Spark, you can use Spark cluster. So you can use the cluster. So storage is, please understand, storage can be different. Processing language can be different. And the cluster in the sense of the machines you are using, right? This machine can be Spark cluster, Hadoop cluster, or totally different cluster. So cluster can be different, processing language can be different, and storage can be different. So you get a significant, what you call, a flexibility if you're using Hadoop version 2. So Hadoop version 2 is in practice right now. At this moment, no one is using Hadoop version 1 because Hadoop version 1 has a significant limitations. Hadoop version 2 give you significant flexibility. You can have any cluster. You can have Spark cluster. You can have one program running an AWS cluster, one program running in your cluster, Spark cluster, Azure cluster, and that resource manager allows cluster management also. You can write some program in Spark. You can write some program in MapReduce, and you can use different type of programming language Hadoop version 2 supports. Hadoop version 2 also supports storage. You can use S3 storage, you can use HDFS storage, you can use other storage also. So having this feature, Hadoop version 2 become instant successful. And most of the company right now using Hadoop 3.x, but that is depend on Hadoop version 2 architecture. It is known as a yarn. Remember lens? We talk about two lens. What do you guys think? People on phone?
First, it stores the actual data in HDFS.
That's the correct answer. Very good. Good. Next one.
Checker.
Which of the following process is responsible for dividing into input data to split for the
Job
processing?
tracker.
So this is 1 second. It should be 1 second. It's splitting processing to MapReduce. It's so which of the following process is responsible for dividing input data? It's not a program. It's input data. It's an input data, not a program. Program is job taker. Input data into split processing. So they are referring to this one. Input data. It's not a program, so they are referring to this one. Right? Input data. Slicer. Who is slicer? Basically, they're asking who is slicer.
Which one was the right answer?
Input.
So were you saying it wasn't the correct answer?
Input
job
form.
Oh, okay. Thank you. The last one. Scheduling.
This looks correct because resource manager is like a restaurant manager, and he making sure waiters are working, right? Tables are utilized properly, right? Chefs are working. So that's what, who is going to go where, who is going to do that. So that type of thing. So this looks, do you guys agree? Good. Remember I said something, minimum, how many copies? Data replications. So by default, Hadoop creates 3 replica.
3 copies.
Right? So by using that, if one node fail, you will not lose the data. So good.
B.
P execution
second.
jobs in smaller units.
See, first of all, real data time processing is definitely not right. Right? Now, scheduling job dynamically. So first of all, batch processing this doesn't look right too, right? So now out of these two, which one would be the correct answer? So execution of jobs in a smaller unit, right? And processing of large volume of data in one go. So this, out of this, which one you guys think?
Both.
Processing a large volume of data in one go.
Third one, I think, processing of large data.
This looks correct to me,
Yeah.
right? Large volume. So batch processing. Good. Next one.
Memory.
In memory, it provides faster memory.
Okay, next one.
Job tracker.
Do you guys agree? Yeah. Correct.
Yarn.
No, resource manager. Yarn is the Hadoop version 2 name. This is the name of that. So resource manager. Job taker is now gone, and now they made it resource
manager.
Yarn is the name of the Hadoop version 2. It's a name of Hadoop version 2. Right. So you may need to create an account. So if you don't have an account, you need to create it. And I think it does ask credit card, right? It takes 1 minute to create an account. Should not. You can go get it if you want credit card. Yeah. So it may take 1 minute to create an account, because just setting up this information. After that, we're going to create EMR. EMR stands for Elastic Map Reduce. Elastic Map Reduce. Elastic Map Reduce is nothing but same concept which we have been talking. We will have a resource manager. So here we normally call master node. Master node here is a resource manager. It's all open.
And it was locked when I.
Let me check. This side. So first we'll create an elastic MapReduce, and in that we'll have option to select master node and how many data node we need to create. So we call worker node or something. So we'll use 1. So no issue, because just to give idea, for 1 hour, it may charge us approximately $1.45. Approximately it will charge per 1 hour. So what we'll do is we'll use that, and before we go home, we'll destroy it. Otherwise, it's going to charge a lot of money. So we have to destroy it. So it's very important that we create it and we'll destroy it. But once we create it, then after we create, we can log in through browser. So you don't have to install anything, which is a good thing. Login through browser. So even though you don't have a Hadoop install, you can still do the exercise. So you don't have to install Hadoop. If you have a Hadoop installed, you can do the same exercise in your local machine, and you may save some money. You don't have to spend $1.45 every time. But if you have Hadoop installed, just like last week we installed Cloudera, then you can use all locally, no problem. Everything will work locally. But the benefit of EMR, first, your latest and greatest Hadoop. There are certain things you will learn, it's like cloud, because if you go in real life, most likely either you will be using EMR or you will be using HD inside. Then you log in through browser. And when we log in through browser, we'll do HDFS commands. So we'll do HDFS commands, and we'll learn the HDFS command, how it works. So my goal here is to cover approximately 10 commands, and that way will give you opportunity to do homework, because when you know the command, you can do homework. Please understand, if you are going to work in Hadoop, you must know HDFS command. And those are not like very complex command. Those who know Linux, it's very similar as Linux. So if you know Linux command, you already know HDFS command. So it's not a rocket science, but our goal is to make sure we learn HDFS commands. So that's what our intention. And once we are done, we are done for the day. Sounds good? Any question, concerns, doubt? Okay. So anyone in the class do not have AWS account? I'm going to show you how to create an AWS account. It may take a minute, depends on how you type your first name, last name, and other informations. Make sure you use your phone number. They may send you text also. They may ask you credit card. Then again, to be honest with you, if you are using this class, you should know cloud, because you know most likely you're going to use cloud. So it's important that you create an account, but remember, before we go home, we want to destroy it. Otherwise, it's going to charge us a lot of money. So it's very important. Good. So let's go and we'll start our AWS console and we'll try to log in. So first thing first, let's go to our browser. Any browser is fine. Go to browser. You do not need AWS install. Just use a browser, normal browser, and then type here AWS Management Console. AWS Management Console. Please type AWS Management Console. AWS Management Console. And when you do AWS Management Console, you will have options like this, AWS Management Console. So you may want to click on that. AWS Management Console. So click on that. So when you click on AWS Management Console, click on AWS Management Console, you will be prompted to log in. If you have an account, you can log in. If you don't have an account, you can start. So I'm starting AWS Management Console. And if you do not have an account, you may want to start create an account. So you can say create free account. By default, initially you get a free account. You can create that free account for certain, I think 1 year you get a free account. You can play around. They still charge, but you can get some resources at $0 cost. Those who haven't, those who have already an account, they may go to here, signing in a console. So this is one who already have an account. And those who do not have an account, they can click here and follow the flow. So like example, if I click here, it will start your, hey, give me your first name, email address and all, and you follow this flow. You give your email address, give your account name. Account name means you just write your first name only, don't give space. Here you give your email address. It will send you link, follow the steps. Somewhere it will ask credit card or phone number. It will send you text, and after a few minutes, you will be able to log in. For me, I already have an account, so I cannot go through this route. I will go through existing user route, means I can log in. Those who are new user, they can go through this route and create an account. It may take a minute or two to create an account, follow the flow. Make sure you use your appropriate email address, remember your password, because this will be a root information. So you need to remember that. And AWS are pretty strict, so it's pretty hard to get your password back if you forgot. Okay. So I have my question.
Should we select business or personal?
Personal.
Personal.
You all should do personal.
Okay. Thank you.
I do have my account, but you guys you need to use your own, whichever you have. I'm thinking like many of you are having a software installation issue. We will use EMR. I have to change my lab accordingly because I have created all lab based on Cloudera, but I will do some tweaking. That way you all can do the lab through cloud and you don't have to install Cloudera. But if you have installed, you can do the same lab in a Cloudera also for practice, and you will save money. Either way is fine. Okay. Now, follow the flow. I will be doing meanwhile. I'm going to log in. So when I log in, I will be logging always as a root, because those who have account, they log in as a root, right? And then once you log in as a root, they may ask email address and password. So when you log in, make sure you use your email address which you use for your account creation. So those who have created email address for account creation, you use it and click on next. So when you click on next, for me, it will ask me my password, and then it will ask me my MFA code, because nowadays they're mandatory making the MFA code for root account. So anytime you are creating an account, they may ask you to create MFA. So right now I'm entering my password and it is asking my MFA, which is coming to my phone. MFA stands for multi-factor authentication. It's going to come to my phone and I need to enter the information here. So and submit. So I should be able to log in. So you can see I'm able to log in. Let me know if you are able to log in after creating a new account, then we'll go over. I'll wait for a few minutes. So you can create the account. Those who want to take a break, you can take a break. Maybe we can do one thing. While you're creating account, some of you are creating, it's time for us to take excellent break. So we can root, there should be a button called root. So when you log in, you need to click on the root and you have to enter your email address. So when you log in, you have to click here, signing with the root user. Then you enter your email address. When you are opening an account, after that, when you log in, make sure you click I'm logging as a root user, root. When you log in with the root user, you will be able to enter your email address and then you have to enter your password. Once you enter a password, you are in. Good. Right now, you can skip MFA. I'm hoping all of you are here so we can get started. Okay. A little bit different, but you are logged in, right? You will see something like this here. Yes?
Yeah, I do.
Perfect. So, Bhumika, are you good? Emma?
Yes.
Good, good. Okay, so let's start. We're going to create a EMR. EMR stands for Elastic Map Reduce, which is nothing but Hadoop in cloud. So let's search here EMR. Search EMR. So when you search EMR, you will see Manage Hadoop Framework, EMR. Let's click on it. So when you click on that, you will see that the screen will change. So when you click on EMR, click on EMR and your screen will change and it will be like this. Your screen and my screen will be a little bit different because I have my clusters are there. So you will have something called EMR. Do you guys see that? Yes or no?
Or not. It's not my doing.
Did you do EMR?
Yeah.
What is this? Public registration. Next one. Oh, you just registered. That's why. You have not finished. You have to complete your registration. Yeah. You are taking a basic support free. Yeah. Continue. So you have not yet completed your account activity. Now you're in. So now you're in. Yeah. Now you say continue. Yeah. This one. Yeah. Click on that. And then search EMR. Search EMR. Now click on this. No, you have it. Yeah. Yeah, because you just created, so it may not allow you. That's why, because it takes 24 hours.
Oh,
So you may,
I cannot.
yeah, you may not be able to do exactly lab right now because you just created an account, so they may take a little time because they want to validate your informations. But
I need to log out.
it doesn't matter. You can just view right now. Those who are able to log in, please understand how did I came here? I came through EMR and I click on the EMR link. You can see here, so you will understand how it works. And then I came to EMR, right? Now, when I click on EMR, I come here. Now, many of you will have something, you may not see this thing because this is something I have before. So right now, we are able to click on this create cluster. So feel free and we'll try to create a basic cluster. We are not going to configure too much. So quickly we can create a cluster. Please pay attention and you can see that. In coming class, I'll also show you how to use putty and connect to the cluster. I will show you how to do other thing and connect. But today I'm going to do quickly create a cluster. Next week also I'm going to show you this process. So by the time you may have an account and you will be able to do that. Make sure you have an account by next week because next week when we do peak programming, we'll be using a cluster. So right now I'm here. I click on create cluster. So when I click create cluster, my screen will show up like this. Please understand. First, it will ask you what will be the cluster name. So you can give any name you want. So right now, let's say I have January, which is the date? January 10th. So I can say Jan 10, right? 10 cluster. So I can create that Jan 10 cluster. Jan 10 cluster. You can write the cluster name. Jan 10 cluster. Makes sense? Jan 10 cluster. So I can give any name of my cluster. Then here is the version, which is the AWS managed version. It's nothing but it's a package, just like Cloudera has a Cloudera distribution. They call Cloudera distributions, and they have version 5.2, 5.3, 5. This same thing. EMR has a version. It means it's a package with multiple software. The thing I like about EMR and Cloudera, it comes with bunch of software together. So right now we are going to select the first one, 7.6. We select, and there are application bundle. So if you are focusing on Spark, we can focus on Spark. Right now we are not doing Spark. we are more focused on Hadoop. So we're going to click on this, right? So we're going to click on Hadoop. So we selected. So when you selected, it says this bundle will come with Hue, Pig, Hadoop, Hive. So basically, I want to teach you Pig. In next 2 weeks, I'll teach you Pig. I want to teach you Hive. All what I need is here, right? And then if I want to enable Spark, I can enable also. But right now, this one come predefined, means these are by default available. Now, this stage is nothing but resource manager. I don't need to. So I'm going to keep it like that. If I don't need anything, I can uncheck, or if anything, let's example, those who like Python, and if you want Jupyter, you can do that also. There are so many things you can do as well. So right now I'm going to keep by default, no change. The only thing I selected is this one, and I selected this one. Now moving along. If you go down, it is going to ask you what kind of cluster configurations you need to do. So uniform instance group means choose the EC2 instance type and purchasing options. So right now we are doing on demand. On demand means as I complete my part, I will have machines ready. So this is default, we'll keep it. Now, if you scroll down, it says primary. What machines we're going to use? So because Hadoop require a lot of what you call speed and all, so we are using M5 large, which is a 4-core 16 GB machine. So think about your laptop on demand. So it will charge almost, I would say, 0.192 per instance. They're going to charge on demand price per hour. And we will have a couple of machines. One will be master, one will be node. So here, I'm not changing it. Keep it default, no problem. So you can see here, one is a primary node, then core node, and the task one, all those are there. So it's going to create 3 machines for us. Again, we'll keep it like that. We are not changing here. So primary and the core, which we are having, and then task node, which we have. So total 3 machines we have. These are hard drive. I'm not changing hard drive because we are not doing big thing here. We are keeping the hard drive, the whatever the default value we have. Now, as you go further, it says cluster scalability. Cluster scalability means like if I get a lot of jobs to the resource manager, do I want my cluster to scale automatically? And when job decrease, does it scale down? If you want to do that, then you can give EMR scalability. Though in this case, in a real life, you do this type of thing. In real life, you do this thing. But because you are doing training purpose, we'll do this because we are saying I don't need to scale. If I need, I will do manually. But in real life, if you work in a company, most likely either you do this one or you're going to do this one. In that case, example, if you're Black Friday, it's going to scale automatically. And if you don't need large machine or large resources, it will automatically scale down. So this is like a cost effective. When you have large volume or your workload is up and down, you may want to use it. Right now, we're going to keep it default. Now you can see here, they are saying how many provisioning we are doing. So we are actually provisioning 2 machines. One is core and one is task one. So these are type of machines we are doing that. Now, if you scroll down, it says what networking you need. I'm not going to teach you all the networking and all. You normally study all those things in AWS class. So in case if you are planning to take AWS class, you will study the security services. VPC stands for Virtual Private Cloud. It means my cluster only will be accessible to me, and your cluster will have your own thing. So again, we don't have to worry about that. Now scroll down. So as you scroll down, the first thing I want you to do is it's going to ask you, you want to create a key. This key is just like in a normal machine, you have username and password. In AWS, normally you create a key. So what is key? So key is like only that key through you can connect to the machine. So if you have a key, make sure you download the key and keep it safe. So using that key, you can connect to the machine. But today we're going to create a key. So let's click on create a key pair. This is just like username and password, but rather than entering username and password, you are using key to connect to the machine. So let's click on it. So when you click on this, it's going to ask you what type of key you want to create. So when you, sorry, my mistake, it should have done, yeah, here, perfect. So it's going to ask me what type of key you want. So we're going to give a name to the key. So here I'll say today is Jan 10. So I'll say my Jan 10 key, right? You can give any name of your choice, and we're gonna select PEM. Try to select PEM because PEM is more generic. Using PEM, you can do PPK, and you can do all things. So normally my choice is PEM. So I select PEM. This is like a format. This format is Amazon private key format. They are using the PEM format, and PPK is like public private key. So that format is normally PuTTY use, and this is very open access key. Again, they have a certificate. That's all it has, certificate. But this is a Amazon use this key in order to access, and most of the software like PuTTY and all, they use public private key. So they use this key. Now, sometime what happen if you don't have PEM, going this is not possible, but going this is very possible. So having PEM, you can do anything, but having PPK, you will have limitations. So I always use PEM. Now, please understand, once you create a key, please understand, once you create a key, you are going to click on create a key pair. So when you click on create key pair, it will automatically download the key. It will automatically download the key for you. So check it out. So if I click on create key pair, it will start downloading. You see that it downloaded. Instantly it downloaded the key. The key name is here. Now, I done the key. So you can see here my key is downloaded and I'm in different window. I'm going to go back to the main window. So far so good. And then I'll use my key in my cluster. It means my machine, I can log in through this key. So far, are you guys with me? Any questions so far? Okay. So now I'm going to click on this one and I'm going to refresh. So I need to use the key which I generated. So I'm going to click here and I'm going to refresh. So I click here, and if I don't see my key, sometime I need to refresh. So I'll click on browse. I click on browse, and if I don't see my key, like my Jan, so you can see I do not see my key here, then I click on this refresh. So I click on the refresh. So when I refresh, you can see now my key is visible. I click on that, right? My key is visible and I choose, and that key is visible here. So let me repeat one more time. So when you click create a key, give a name on the key, select the PEM, select a PEM, it will download your machine. After that, click on browse, refresh it, select the key, and when you select the key and say okay, your key will show up here. If you don't select the key, then you will not be able to log into that box without key. So it's important that you select the key name. Now, moving ahead, we are creating EMR service. So by default, we keep existing one, no problem. We are not thinking. Now here we need to change a profile for Amazon. So here we're going to say create instance profile. So it's a new instance profile so that you can specify custom resources. So I'm going to click on this one. So it will create a profile for us. So again, it will create a profile and it will also use bucket and all. Again, we are not going to focus on right now the bucket. I'll cover in detail as we go further. Right now, just select this one. So at this moment, we are almost ready to create a cluster. I don't think you need to give anything else. So let me just go over a few things one more time. Just want to make sure you understand. First, I entered the cluster name. Then I selected the EMR. Then I select the Hadoop. Then I kept the default one. I went down. I didn't change anything. The by default, whatever the specs, it's selected instance type. I kept that. I went down. All the options so far we have selected manually, and we are selecting 2 nodes. We didn't change the VPC or anything. We kept it default. Then we went down. The most important part we did is that we created a key. And then we select the key using browse, and then key listed here. We didn't change any role, service role and all. The only thing we have done when it came in EC2 instance profile, we selected the default profile. We say create instance profile. Now if you scroll down, and everything looks good to me at this moment. So you can see here, there's a button called create cluster. So I'm going to create a cluster. Normally create cluster means it's going to create 2 machines. These machines will be EC2 machines, and one machines will be a master node and one will be data node. For training purpose, this is good enough. It may take 3 to 4 minutes to create a cluster. So let's click on create a cluster. it's asking you must resolve all errors. So you can asking service role. So we can say create a service role. Sorry, we need to say create service role. We can give option that, hey, create a service role for me, right? And now create cluster. Now it's creating cluster, may take a couple of minutes. Again, right now you can see here, it's creating a cluster. So when it create a cluster, your screen will be visible and then it will give me options how to connect to the cluster. So right now it's creating a cluster. It takes a minute or two. And now you can see your cluster request has been successful. So my request has been successful. Now, please understand, when you are sending this request, what happened at this moment, it is creating, or I would say provisioning 2 machines. So it provisioned 2 machines in a cloud, and then it will install Linux, then it will install Hadoop, then it will install all the software for me. All those things is going to happen in a couple of minutes. So right now, think about that, just like last time you installed, like, some software. Same thing here, it will create a machine, it will install Linux, it will install Hadoop, it will install all the necessary software. So it is going through the journey. Now, while it is going through the journey, it is possible that you want to know what's going on here. So you can see there are so many options available. Now, at this moment, it says successfully created. Now you have 3 options. You can refresh, so updated less than a minute. Terminate means you can stop it. Status is starting, right? So if you want to terminate, like example, when we are done for the day, we can terminate it. Terminate means you're destroying, but right now it's starting. So let it go as we go further. Now, at this moment, what happened is our machine, we are not yet successful, but as the machine is ready, it is going to give us primary node and we can connect to that machine. But right now the machine is not yet ready because it's provisioning machine, it's installing that thing. When it install, it will install all the software for us. So it's going to take time. I'm going to refresh here just to give a demo, and you can see here it's almost done. So now you can see I got a link here and it says my machine is ready, primary node is ready. So I can refresh 1 second, but you can see now it's giving me option. People on phone, are you guys able to see this option? Good. At least one person gave thumbs up today. Most of you guys need to give me some response. Pretty good.
I can see only one link.
Sorry, one link. Refresh.
Yeah,
it.
I can see.
Yeah, you can refresh and you will see 2 links. Right. So this SSM is like you can use your browser to connect to your master node. In coming class, I'll use SSH, but you have to use key which we downloaded, PEM key. Using key, we can use a putty and then we'll connect. So in coming class, we'll be able to do that part. But this one requires a little bit extra step, which we'll cover next week. Right now, I want to show you quick and easy way how to using this one, you can connect to the machine. So right now, creating Linux box is very fast and it is giving me link. So if you click on that, you should be able to connect to EMR and say, ta-da! So now you are here. So it says, do you want to connect? So right now my machine has a public IP and I'm trying to connect. If machine is ready to go, I should be able to connect. So if I say connect, and if it's successful, I should see EMR. It takes some time, couple of minutes, but overall it's within 3 to 4 minutes. It takes 3 minutes around. After 3 minutes, you can be able to connect. While you're able to connect, I'm just going to walk you through so you can make use of the time. You just need to go back and refresh and try to connect. So what happened when you connect, you will see like this EMR, right? I show you step by step how I connected, right? Behind the scene, it created multiple machines. You can see it created multiple machines, right? So right now, all the machines are created. Machines are created because I was running. So these machines, who created? EMR created. So EMR created, it created a name node, master node, and it created data node. It installed the software, and through browser, I'm able to connect to this one. So now I can use both node by connecting this. So when I connected here, I'm actually connected to the master node.
Yes.
Right? So now the only way we will be able to connect is going through this box only. Remember, try not to do connect. You're turning to SSM, right? And this is your primary node, right? Are you
How to go back to this page?
tab through tab?
Okay. Okay.
Right? Through tab, you can go back. If you miss the tab, you can search EMR, right? You can search EMR.
Yes.
You can click on EMR, search EMR, and your cluster is running. You can see right now it's running, right? And then you can click on that, right? And when you are here, you can see status is right now still waiting. But if I click on SSM, I'm able to connect. So I'm able to come here. When I come here, my everything is there. So I'm having public, no problem. And what is the username you're using? Root, right?
Yes.
Right. So by default is connect, and then you just say connect. I'm not doing anything special. So connect, and you should be able to go in.
So from this page, you can write your code.
I'm going to show you so you guys can see how it works. Emma, you are also having a problem?
Yeah, it says I can't connect. It did give me an article just to troubleshoot. So go ahead, I'll catch up.
So the way it normally happens when you are not able to connect, the reason couple of things happen. Remember we created a key and we created a role. So if you are not selected the key properly, then you will not be able to connect. So that's why sometimes you might have missed one step. Possibility is there that you may, or sometimes it may take time, depends on the need, but eventually you will be able to connect. So now when you are connected, what should we do? So this is your prompt, and here we can run HDFS command. So what I'm going to do in our forum, if you notice the forum, the Hadoop forum, all those HDFS commands are listed here. So I'm going to show you HDFS commands step by step. The last week we did not do proper homework. So today I explained Hadoop architecture. So you guys are going to do homework, right? And we are now doing HDFS command. So HDFS command, how is going to work? Those who do not know Linux, I added a video. I would strongly suggest you watch the video. And there is a HDFS command, step by steps are here. So we're going to do some of the command, and each command I'm going to walk you through and explain it. Okay? I'm recording the sessions so you can see that. So each command kind of goes through step by step. So you start with Hadoop, and then you say FS. FS means file system. And then you always have a dash, and then command. So I'm going to explain as we go further. So you can see step by step. So I'm here, and I'm going to make it a little bigger. So let's say I want to see my Hadoop files. So I'll say Hadoop. Command is Hadoop lowercase fs, and then minus ls. ls means list. ls means list, and then I can say dot means current directory. So if I enter right now, there is nothing in a current directory because I have not created it. Current directory means whenever I use current directory, it means I'm talking about my profile. But if I say Hadoop fs minus ls and I do / means I'm talking about root directory. So in that case, it will show me that how many directory exist in the root. So in Linux, you have / is a root volume, and you have this many directory exist.
What is FS stand for?
File system. So Hadoop FS, ls stands for list. So you will be often using that, how many files you have, how many files you created, like that. You will be often using it. So now ls stands for list file. Now this is all very similar as a Linux. So let's say I want to create a directory. I want to create directory in a Hadoop. Let's say I want to create a directory in Hadoop. So how do I create it? So most likely you are not going to be able to create directory in a root location because you may have permission problem because this is the owner. and there's a group. So you may have a problem with that, but you will be able to create in a current directory, which is the dot. Current directory means yours. You can do whatever you want. So I'm going to create a directory. If I want to clear the screen, I write a clear. So clear the screen so I can go up a little bit so you can see better. So let's say I want to create directory. So I'll say Hadoop, right? Space fs space dash. Dash means now Linux command. After dash, you write Linux command. So Hadoop fs is the Hadoop command, which is a HDFS command, then dash mkdir. Mkdir means make directory. Then you can give a directory name. So let's example, I'll say in dot means current directory. I want to create directory number 1. So I'm creating directory number 1. So it will try to create a directory 1. Let's say I want to create a directory number 2. So in Linux, you can use up arrow, so you can have previous command, up arrow, so you can have previous command, and you can say directory number 2. So I'm now created 2 directory. Directory is nothing but folder. So far, so good. So Hadoop fs minus mkdir. So you're creating directory, and dot means current, and you're creating 2 directory. So here we created 2 directories. Directory is nothing but folder. Correct. So I want to see how should I see the directory corrected. I'm just pressing some enter just to give a space. So I'll say Hadoop fs minus ls. Ls means list, and then I said dot. Dot means current directory. So I'll see now I have 2 directory created. Make sense? So when I created 2 directory, you can see the timestamps. It will take today's date, and it will give you timestamps also. I'm going to do all. Yeah, I'm going to do all. Yeah, there are 9 to 10 commands I'm going to show you. But any question how to create directory? Right? What is the mkdir stands for? Make directory, right? So now let's say I want to create a file. So if I want to create a file, I can use a Linux command. So there's a command called echo. Echo is a Linux command. I can say double quotation. I can give a message. This is my simple file. Message. A double quotation complete, and I can say greater than, and I say my file. This is my file. So what I'm saying here, echo this message, which is in double quotation. This means write. Greater than means write to this file. So we are saying create this file with this message. We are saying create this file in this message. I use command echo. Echo command will create file in my local machine. I'm right now in local machine. So I will create this file is created in local machine. And then using Hadoop command, I'll copy this file into HDFS.
Content comes first, then we assign the file.
Yeah, I would not say like that. These are command. Echo is the command. Make sure you understand first. Command. This is the command. This is the message or content, and this is the file. Each command is different. So this is the structure. So echo in double quotation, you write a message. Greater than means write. So this file will be created in Linux. So there are 2 things. Please understand. In this machine, there are 2 things. If I don't write Hadoop, and if I write a command, that's a Linux command. But if I write Hadoop fs like this, it means I'm writing HDFS command. So HDFS command is specific command. Linux command is just like that. And I'm going to show you how to push the file from Linux machine to Hadoop. And I'm also going to show you how to bring file from Hadoop to Linux. Make sense? So you can understand how it will work. So right now, if I press enter, I created a file. Please understand, I did not use Hadoop command. If I did not use Hadoop command, then this file is created in a Linux box, and the file name is this. So if I want to see what is the content in the file, what is the content in the file, then command is very simple. You can just say cat and then file name. As you can see that cat means you are showing the content. So you are showing the file content. So you're saying file content cat. So this file, what the content you have. So whatever we wrote, remember we wrote this thing, we are seeing that. So cat through we see this file content and we got this message. So far we are in Linux. This file is in Linux. Now what I really want, I want to push this file. I want to push this file to directory 1. And directory 1 is in HDFS. You can see right now, directory 1 is in HDFS because we created this file using HDFS command. So now we have local file. This is the local file. And I want to put that file in a HDFS. So how do I do that? So check it out. Please pay attention. So first you say Hadoop, right? First you say Hadoop. Then you're going to say FS. What is FS stands for? File system. Hadoop FS. FS means file system. Then you're going to say, what is the file name? So I want to push the file. So I'll say put. Put means copy. Put means copy. I'm pushing the file. What is my file name? My file. And where am I pushing that file? So I say current dir1 directory. So I'm pushing. How do I read this thing? So you're saying Hadoop FS. This is called HDFS command. Put this local file into HDFS directory. So I'm pushing this file. Though file will be here as well as file will be copied. So now after this command, my file will be also copied into directory 1. Now you press enter. So when you press enter, the file is copied. Now, if you want to copy the same file in directory 2, same command is that Hadoop fs -put my file dot directory 2. So you are now push that same file into 2 directory. Now, please understand here, this is the local file and this is the HDFS. So now if you want to know, did I really push this file to HDFS folder? So for that, we can use a command like this, Hadoop fs. Fs means file system, -ls. ls means list. And then I can say dot dir1. If I press enter, if my file is there, it will show. So you can see here, I can literally see that when I run this command, I can see that dir has my file because I copy my file in dir1. Make sense? So when I say dir1, show me all file under dir1 directory. So I can see my file is there because I pushed it. Same thing if I do Hadoop fs -ls dot dir2. What will happen? I still have a file because I copied that file. So my both command works very nicely. I was able to copy file into both directory and I'm successfully verified that. Now I want to know what is the content in this file. I want to know what is the content in the file. The file itself is in HDFS and I want to know content. So how do I run the command? So if I want to run this command Linux, I use cat command. If I want to run in HDFS, what would be command? So command will be very similar, Hadoop fs. If you want to run command in HDFS, then you can say dat -cat because you are running Linux command on HDFS. So anytime you are using Hadoop fs means you are running HDFS command -Linux command and then your file path. So my here directory 1 has my file. So if I write that, I can see the message. I will see the message which I have. Please understand, same message I can see here, but this file is in HDFS. I'm running Linux command cat using HDFS command. Any questions so far? It is. It just requires a little practice. People on phone, so far so good. Yeah. So first, let me show you how to bring the file. So if you want to bring the file, so now let's understand the use case. You have file. This is the file which is exist in HDFS. So file exists in HDFS. Let's say I want to bring this file into local machine with some name. I want to give some name, local machine. I can do that. So while you're pushing the file to HDFS, you use command put. So local file went to Hadoop. Local file went to Hadoop through put command. So if you want to do reverse, you're going to do get command. What are you going to do? Get. So from HDFS, you're getting the file and bringing to the Linux. So let's see here. So I'm going to give some space. So I'll say Hadoop fs -get. Get means I'm reading. So what am I reading? So I'm reading the source. So when I'm reading the source, so .dir1, that's my directory 1, my file, and what name I want to give. So this is my new file. Let's say I say new file. So I'm saying that Hadoop get, this is the existing HDFS directory, HDFS existing directory and file. get that file and name this thing as this. So this will be my Linux file because I'm getting from HDFS and renaming as a new file. So my new file will be created in my Linux box. So I'm getting from HDFS and bringing to Linux box. Now if I press enter, it's going to get me that file. So it got it. And if I do cat new file, as you can see, I'm running Linux command, I will see the same content because this file is now brought it in. So it brought in Linux box. So if I do cat Linux, I get the same file. And if I do ls minus l, ls space minus l, ls space minus l, I should see two files. You will see two files. The first original file, I had a my file, and this command got from HDFS this file. So this is my second file, and the second file is also visible here. Any questions so far? People on phone? This is similar work in Cloudera. This works in anywhere in the world. As long as you're working on Hadoop, this is the only way you work with files through HDFS command. So anytime you work with HDFS command, you just need to run this thing. So if you want to push file from your local machine to Hadoop, you do put command. If you are bringing file from Hadoop to local machine, then you do get command. Now, if you want to see the file, so there are commands are there, right? Cat command, where you can see the content. Cat command through, you can see the content. But if you want to move file, then you can do MV. MV means move file. So example, you have one file which is in a Hadoop directory 1, and you want to bring that file to Hadoop directory 2. You can do that. So you're moving, means you are removing from here and you're bringing here. But if you want a copy file, you can do copy. In that original file will be here, and you can have this file here. I'm going to show you that also. And there is one more command called RM. RM means remove. So there are 4 or 5 commands, and you're good to go, right? It's a Linux command. So I'm going to show you step by step. Okay. So now let's get started. So first thing we'll do move. So please understand. First, I'll show you again. So like Hadoop fs minus cat, and I'll say dot current directory. So it's a directory 1 and my file. So this file exists, right? This file exists, my file. Now, what I really want to do is I want to create directory number 3. Please pay attention. I want to create directory number 3 in a HDFS, and I want to copy this file here, copy. So what I'm doing, HDFS, I'm in HDFS, file is in HDFS, in one directory, I want to copy to another directory. So I'm transferring file from one HDFS to another HDFS. So how do I do that? So let's first create the directory. So I'll say Hadoop fs mkdir, then I'll say I want to create directory number 3. So far so good. So I'm creating directory number 3. You know that I just created directory number 3. Now I wanna copy this file to this directory. So I want to transfer HDFS to HDFS. So how should I do that? Very simple. Hadoop fs dash cp. Cp means copy. Cp means copy. What is the source? So source is here. So dot dir 1 my file. That's my source. Now where I want to copy. So directory 3. So here when I say copy, my source will have the file and my target will also have a file. So you're copying the file like this. Makes sense? So now if you press enter, your file is copied, and now you have 2 copies. And you can check that by running cat command Hadoop fs cat dot dir 3, and you can say my file. So you can see that cat command through, I can read directory 3 my file, and you can see the file will be visible. Make sense? Now I will show you move command. So what I'm going to do, I'm going to create another directory called directory 4. Please pay attention. I'm going to create directory 4, and I'm going to move this file which is in directory 1 to directory 4. When I move it, original file will be gone and it will move to new file. Make sense? Copy file, copy command. When you do copy command, original file and target both will have same file. Move command, move original file to the target. It means you will lose this file in a source. So let's see that how it works. So for that, first I'll create a directory, Hadoop fs correct mkdir, and I'll say dot dir 4. So I created directory number 4. So I created directory 4. Now directory 4 does not have any content. Now I'm going to say Hadoop fs dash mv. Mv means move. What's the original source? So original source is directory 1, my file. That's the original source. And what would be the target? So target will be directory 4. So if you read in English, the way it says that this is the original file, move this file here. It means after moving, this file will be gone, and then this will be copied here. So if you press enter, now I have directory 4 should have a file, and directory 1 will not have. So example, if I say cat command, sorry, my mistake, Hadoop fs minus cat, and if I try to do dot dir1, my file, you will not see that content. File won't be available because you moved it, right? But if I say Hadoop fs dash cat dot dir4, my file, and you will see the content because you moved there. This is not a code. No, this is not a code. This is called command. This is nothing. It's a code command. Like you will be doing a lot often, because remember, you are working on data. So if you're working on data, your large volume of data, somewhere you have to store, somewhere you need to move. These are data operations. And there are only 10 commands you need to know. Only 10. So CP stands for copy, MV stands for move, cat stands for content, LS stands for list. Now I want to remove this file. So I want to remove this file from directory 4. So if I want to remove this file from directory 4, there's a command called rm. Rm means remove, rm means remove, and R means recursive. R means recursive. So check it out. So now I'm going to remove this file from directory 4. So how should I do that? So Hadoop fs minus rm dash r. R means recursive. Then you are saying go to directory 4 and remove my file. So you're removing that direct file, my file. So now you delete it. Now if I want to try Hadoop fs minus cat, and I say directory 4, my file, I'll not have see the file because file is gone. File is gone, right? If I want to say Hadoop fs minus ls dot dir4, you will not see anything because there is no file there. If you want a clear screen, what is the command? Clear. Clear screen will be clear. So if you see in this example, in my Hadoop example, I have a lot of example here how Hadoop commands work, ls commands, how ls command works with command, and there are examples are there, commands, and there are examples are there. So you can literally see that if you want recursive something, you can do recursive command also. So example, if you want to do some recursive, like you want to see everything, so you can say Hadoop, right? Hadoop fs, right? Hadoop fs dash ls minus r, and then you can say, you know what, I want to know directory 2. So sorry, my mistake, Hadoop spelling is incorrect, right? So you can recursively run the commands. So if your directory, subdirectory, files, you can see all the files, all the directories. And this is beautiful, right? Good news about the commands are step by step. So if you go further here, oops, now get command.
Local in the
Cloud. So the way, good question. So I have this file which I have, let's example ls minus l, right? So if I want to transfer this file to my local machine, there are local machine means my, let's say my Windows machine. Let's say this is my Windows machine. This information is in cloud. So there are a couple of options. If I install a file transfer software, like example FileZilla, I'll show you in this class how to do that. So if I install FileZilla, so using FileZilla, I can connect to the box and I can transfer the file between this machine and this machine. So one is that way. So I can install FileZilla, I can transfer, no problem. Or another way I can do is I can install on my Windows machine PuTTY. I can install PuTTY. So I can install PuTTY, and then I can do SSH, and using SSH command, I can download also. So I can download the file also. So you can. So you have to configure that. I'll show you in a coming class how to configure that part. Not a problem. Okay. People on phone so far, are you doing good so far? Okay. So sorry, go ahead.
Yeah, I have still problem with the AWS console, but I performed the 2 days lab in the cloud.
You can do that. Yeah, you can do. So please understand, let's say I'm going to repeat all this exercise quickly so you guys can help me. So if I want to clear the screen, what is the command? Clear screen, right? Let's say I want to create a brand new file. So you can say echo, double quotation, whatever your message you want to give. So this is my second file, right? Double quotation complete greater than second. So this is my second file. And if I want to see the content, I'll say cat second. So I can see the content. Now, if I want to do ls minus l, I can see 3 files. I can see second file is there. Here, this is the permissions. This is the permissions. This is the owner. This is the group, right? And this is my file. Now, I want to create a directory in a Hadoop. So before I can run it. So Hadoop fs minus ls, and then I said dot. So I can see what are the directory you have. So I have this many directory I have in my HDFS. Now let's say I want to create one more directory. So I'll say Hadoop fs dash mkdir. Then I can say directory name. Let's say example, I say directory name. Let's say my directory 1. Let's say my directory 1. I'm going to do with a dot. Dot means current directory. It means I'm going to create a my directory 1. So if I want to check it, I can use up arrow, and I can see that up arrow through I can bring my previous command. So you can see my directory is created. Now I have a second file which is in my local machine. This is my Linux box. I want to push the file here. What is the command? If I want to push the file, command is put, right? So Hadoop, right? Hadoop fs dash put. What is the file name? Second. Where you are pushing to? You're pushing my directory 1. So you're pushing to directory 1. So you push it. And if you want to see the file, what is the command? Hadoop fs cat. And then you can say my dir 1, and the file name is second. So you can see that. If you want to see the file information instead of cat, you can write ls also, and you can see the file creation time. No, then you will not be able to do much. It's required a thing about that. If you don't know your home address, how would you go? Same thing, right? It's like that. So now if you want to move this file to directory 2. So what is the command? How do I move? I'm moving Hadoop directory files to directory 3. How should I do that? Yeah, between Hadoop. So Hadoop fs mv. Mv means move. Where is the source file? Source file exists in my directory 1 second to directory 3, right? So if I press enter, it will move. And if I want to remove, if I want to check it again, so Hadoop fs, right, dash ls, I can say directory 3, right? And if I press enter, I should see the file there, which I copied, which is there, right? If I want to remove from here, what's the command? Hadoop fs minus rm directory 3, right? Directory 3 second. So I can remove that file. So I can remove that file also, right? If I want to know the directory utilizations, I'll say Hadoop fs minus du. Du means directory utilizations, and then you can give a directory name. So you can see how much you use. So you can see the size you used. So you can see the 33 block you have used. So directory utilizations. If you want to know disk fragment means byte use. So you can see the disk fragment also. So you can see how much file system you use. So you can see you use only this thing. Available is this. So you only use 2%. So you can see this fragment means how much percentage of files you use. Fragment means like file system you use. You can see that also. So there are certain commands we will be covering in coming class also. However, if you see in my Google class, what I have done is after all command, I have given some homework. It's simple homework, very simple homework. Like example, create folder, mkdir, create a file, right? Then move the file, copy the file, remove the file, show the content, combine file. So combine file is called merge. So you can merge. So here, combine this one and this one to this one. So you can do that part using merge. So get merge. You can do that. That's your homework. Remove. We talk about rm-r. rm-r. So let me just show you one more time. Let's say if I want to remove directory 3, so you can say Hadoop, right? Fs, Hadoop Fs minus rm space -r, and then you can say dir3. So you are removing the directory. Please understand. Yeah. Yeah. So delete r will be helping you to recursively delete the file, right? And then display file, which you know how ls, and so the content. So all the informations I have defined. Now, any question before we take a Hadoop HDFS quiz? Any questions, concerns before we take a HDFS quiz? Okay, so let's do a quiz. There is a HDFS quiz for you. So here you go. Here you go. Ready, set, go. So what would be the correct answer? So this the command, say which command is used to upload, right? So put command, right? Just to give idea, there are two commands that are almost same thing. So put command, or you can say copy from. Copy from is also command. Get, this is copy to local. Copy to local is nothing but get. So there are two command does almost same thing. So copy to local is a get command, and copy from is a put command. So this is the put. So check it out. Good. Put command. Next one. Display the content of file. Right. First one. Right. Which command is used to change the ownership of a file or directory in HDFS? Ownership. Own. Own means ownership. Ownership means own. Right. So see which command is used to change the ownership of the file. Own. So you can, if you want to change permission, then chmod. So if you want to change the owner means, like example, Mike has created a file and you want to create a Joseph owner, then you can use change ownership. You can say Joseph and the file name. So now this file will be now owned by Joseph. You can do that. Or if you change permissions, you can do. These are advanced command, but this is a file. It's there in our file system, but I'll cover as we go further.
ls.
So list the content of directory in HDFS. So ls. Which command is used to move file within HDFS? MV. Make sense? Right? See how easy it is, right? No, there are only 10 or 12 commands. It's not, you only going to use like 6-7 command often. So it's not like a rocket science. Command to check the disk usage. DU stands for disk usage. Right? Next one, how can you copy file from HDFS to local file system? So you're bringing So copy to local, that's the command. That's the get actually. This is like a both same. This is get and this is a copy from local, it's a put. So you can read in English, copy to local. So copy to local and copy from local. So that's the HDFS put, right? So next one, merge. So merge command will help you. I think it's a get merge if I'm not making a mistake. Get merge. I'm assuming get merge. Yeah, that's a get merge. So you can bring multiple files together. It's right. Doable. Next one. This set replication, and then you give a number. You give a number. So you can give a number how many replications you want to do, and it will do. This, like, you know, there are Hadoop has two type of command. This is like old, when the Hadoop started old, they used to call distributed file system, and then they removed D and then just say FS. Yeah, so they changed that. So you might have seen here they are using HDFS command. If you ask me, some computer will work this way, some computer will work with Hadoop. So different setup you have, but ultimately it is the same thing. So replications, all those things which I am explaining here, if you see in my forum, you will see that all the commands. So there are many more small command are there. So this is the owner command, ownership, right? This is like this one is replication. So you can see here. So you can say Hadoop FS set rep, right? So here it's backward compatibility and you want to have replication, right? So here copy from, right? Copy from and copy to, right? So these are like get and put command kind of things, put and get. Okay? Yeah, this is like a new version. Follow this one, right? So play around this thing, do the homework. All commands are step by step. I explain here how you move from one to here. The pictures are there. Play around. I'm hoping you can do that exercise. Everything has meaning explained here. Play around. That will help you. And once you complete the homework, make sure you upload in a Google Class. But all homework informations are here. Homework 1 and homework 2 is now required because you can use EMR. I would strongly suggest you can do EMR because that way you can work on it. But now it's time for us to complete the class. So what I'm going to do, I'm going to terminate the EMR. If I don't terminate, it's going to cost me a lot of money. So in case if you say I forgot it, you can go to EMR like that, search EMR, click here, and then click on the EMR link. And once you come here, your cluster might be running. So right cluster is running. You can see the cluster is running. So if you click on that, and then you can say, I want to terminate the cluster. So when you terminate the cluster, it will go back and it will destroy both like name node and data node. Both node it will destroy. So this way you don't have to worry about all your resources will be destroyed. It takes a half a second or something, and it will send the request. Now you can close the browser and you will not be charged.